Now we're going to talk about two ways that you can describe sets. The first way that you can describe a set is using what's called list notation. And list notation is you're literally just listing the elements in the set, kind of like what we were doing before. Put curly brackets around the set, separate the elements with commas, make a simple list. The other way is using what's called set builder notation. So what you're doing is you're building a set. So because it's going to be a set, you start by putting curly brackets around it. And you're going to put whatever variable, you want to call it x or n or t or whatever variable, then a straight up and down bar that means such that, and then you put a description of what x is going to look like. So in math, a lot of times you'll have they look like formulas over here. So an example of set builder notation would be, let's say we have the set C. So the set C is equal to, it's a set of all elements x such that x is an element of the natural numbers and x is less than 5. That's the way we read that, and I've got it all spelled out for you here. So it's all x's such that x is an element of the natural numbers, so it's a natural number, and x is less than 5. The reason they have to be specific is because there's an infinite number of numbers that are less than 5, if you consider decimals and fractions. So they had to say natural number. So if they tell us it's a natural number and it's less than 5, then I think that would be these numbers. Those are the numbers that are strictly less than 5. So in list notation, it would be 1, 2, 3, 4. In set builder notation, it would look like this. So that would be, oh, it's set C. We could write it like that. So now we're going to do a bunch of examples. Let's describe each of the sets using list notation and set builder. So the first one is letters in the word pizza. So if I just want to list them, I'm going to start with my curly brackets, and there's a P, then a comma, there's an I, comma, there's a Z, comma, and there's an A. Notice I didn't list Z twice. You don't need to list repeats. That's redundant. We just want to know what letters make up the word pizza. And so it would be these. And you could put them in any order. The order doesn't matter. But don't list any repeats. So if I wanted to write that in set builder notation, there's several ways you can do this. Because this isn't going to be a formula, it's going to kind of look like the list. So we could name the set, whatever name you want to give it. We could call it A. It's a set of x's, I'm going to call them x's, such that x is either, or I could say, let me say this, is an element of this set. Now, this is listing like a set inside of a set. Do you see that? We've got like the big curly brackets on the outside and then the little ones. You could also say it like this. It's x such that x is P, I, Z, or A. You could also say it like that. Either way would be perfectly fine, but this uses the element notation that we just learned. So that's one way to do it. It's kind of hard when it's not numbers. See, when it's letters, it's a little bit harder to write set builder notation. So let's try a different one. We're going to look at here the natural numbers from and including 6 to 10. So the natural numbers, just talking about these nice whole numbers, from and including 6 to 10. So that means if we wanted to write a list, it would be 6, 7, 8, 9, and 10. See, we're including the 6 and the 10. So in a list, it's pretty easy to write. But in set builder notation, it's a little bit harder. So we're going to give it a name. We'll call it A. I'm going to stick with set A today. Curly bracket to start with. It's going to be a bunch of x's, a bunch of things that are going to vary, such that now we need to describe this 6 to 10 and including it using some sort of like mathematical notation. So I'm going to say it like this, using my less than symbols. Now notice they all point to the left. 6 is less than or equal to x, which is less than or equal to 10. So these little equals are including the 6 and the 10. If you didn't want them included, you would take the equals off. But we're including the 6 and the 10. Now there's an infinite number of values in here. You need to tell them that we're talking about only the natural numbers. So then you say x is a natural number. These two statements right here could be switched. The order that you write these statements in doesn't matter, but those both describe x. They tell the reader it's a natural number, and it's between 6 and 10 and including 6 and 10. So how about the positive multiples of 10? Positive multiples of 10. Well, multiples of 10 are going to be bigger than 10 when you multiply 10 by some whole number. So start with 10 and then 20, 30, 40. Now when I intend for the set to go on forever, you put little dots in there. So again, we're in curly brackets, separating with commas, 10, 20, 30, 40, etc., etc. Now we got to say it in a more mathematical way. So I'm going to say, okay, we have set A. It's going to be a set of x's such that, now we have to describe x. Well, x was always like, this is 10 times 1, 10 times 2, 10 times 3, 10 times 4. So if you want to do a multiple of 10, you just say it's 10 times some number. Now I just introduced another variable. What kind of a number were we multiplying by? Not all of the numbers, just 1, 2, 3, 4, basically those natural numbers again. So notice I'm saying x is 10 times some natural number. So two variables inside of this one. But see how it's like a little math equation here? X is 10 times some number where the numbers are natural numbers. And then the positive even numbers. Okay, the positive even numbers, notice it says they're positive and they're even, so I guess we would start with 2, 4, 6, 8, etc., etc. So if I want to list, there's my list with the elements separated with commas, and I put a dot, meaning it goes on forever. Set builder notation is going to be very similar to the last one, except these aren't multiples of 10, they're even, so they're multiples of 2. So it's all x's such that x is 2n, n is a natural number. So these two, again, these are very similar. One's multiples of 10, one is just even. And 2n is how we say even numbers quite a bit. All right, one more. Let's write this following set in list notation. So they're giving us the set in set builder notation and asking us to list it. So it says, it's called set C is equal to, here's a little phrase. Now they did this one a little bit differently. They put the formula here up front. We could have done that, I suppose, but 2k plus 1 such that k is 3, 4, and 5. So they're telling you which numbers to use for k, and they're giving you the formula. So this is an alternative way to write. We could have done this where like the 2n could have been put here at the front, and the 10n up here could have been put at the front. So it's just an alternative way to say it. There's no right or wrong way, really. So what I'm going to do is I'm going to set up a little table. They gave me these k values. They gave me 3, 4, and 5, and the little formula I'm supposed to use is 2k plus 1. So if I plug in a 3 for the k, that would be 6 plus 1, which is 7. If I plug in 4, that would be 8 plus 1, that's 9. If I plug in 5 for the k, that's going to be 11. So this set C consists of 3 elements, 7, 9, and 11. And I wrote it in list notation with commas separating my elements. And this was just sort of my scratch work that I did on the side. So that's how you kind of translate it out of set builder notation into list notation.